Morning Year 12, it's Wednesday when I'm shooting this for Thursday. It's very sunny out here. I can see the top corner of that's a bit glary, but hopefully you'll be alright with this. Okay, it's our second last lesson of the term, trig integration. The last set that we've got to do in this stuff, all about 6E. Now, this is all areas under curves. Pretty straightforward, so I'm doing 3 examples, 2 pretty straightforward ones, and then a logical one that looks hard, but it's not really. Okay, find the area bound by y equals sine 2x, not sine x, sine 2x, x-axis and pi on 4 to pi on 2. Well, sine 2x between 0 and 2 pi, 1, 2, the 2 means the period goes half, so it only goes between 0 and pi. Now between pi on 4 and pi on 2 means it's that bit there. Pretty straightforward and easy kind of area to find. So we're finding the integral from pi on 4 to pi on 2 is sine 2x. We need it in the correct form. So we've got to put a 2 in there and a half out there. Now 2 sine 2x becomes minus cos 2x. So there's a minus a half. Minus goes in there between pi on 4 to pi on 2. Minus. Now we'll put pi on 2 and pi on 4 in there. We get cos pi on 2. Chuck them in the calculator if you can't do them in your head. And we end up with minus a half times minus 1, which is plus a half. Pretty easy. It's got to be a positive area, remember. Okay, now this one's really easy. The question in 7b says find the area between bounded by cos x and y equals x plus 1, and it's drawn there for you, so you didn't have to draw it. So it's this area here. But look, that's a triangle. We've talked about this before with the machine gun to a knife fight, and then that's a very regular area. All these areas are pretty common here. Okay, so triangle, minus 1, 1, so it's a 1 times 1, so it's a half the area there, and then that's the area under cos x from 0 to pi on 2. So cos integrates to sine 0 to pi on 2. Sine of pi on 2 is 1 and 0. Really easy. 3 on 2. 30-second job, that question. Seriously. 7a is harder than 7b. Go back and have a crack. Okay, now look at this one. Question 12. It's all drawn for you. Now, it says y equals x minus sine x and y equals x. X minus sine x is there. Now, it's in the example in the book. Go back a few pages. This question leads you back to that example. And then it says find the area, total area between 0 and 2 pi. So that's that area in there and that area there. Now that and that are always going to be the same all the way off to infinity. So you just got to do that area times by 2. So that area in there is going to be that triangle minus that bit under there times by 2. So that's 2 lots of. Now that's pi and that's pi. So pi on 2 squared, half base height, and then 0 to pi x minus sine x. So even though it's a hard curve, it's easy to do there. X squared on 2, integral of minus sine is plus cos from 0 to pi. Chuck those in, and you've got 2 out the front of pi on 2 squared, so that becomes pi squared. 2 outside of pi on 2 squared minus 1. When you do that with your gadget arms and everything, you get pi squared minus pi squared plus 2 plus 2 gives you, that goes to 0 and that becomes 4. You need to go and look at that quite a few times, I reckon, but it's a very straightforward example that looks, on the first look, a lot of people go, I can't do that, but it's not that hard. Alright, enjoy.